In this video, I want to look at the generators of the cyclic group Zn under its addition. To get started, I want to make a couple of notes. We've already seen in class that Zn under its plus is a cyclic group generated by 1. And of course, we also know that Zn has n elements. So we can tell whether or not an element is a generator of Zn by simply looking at its order. And if its order is equal to n, then the element generates Zn. So I want to actually get at the answer of who generates Zn by a more general question. I want to think about this. If k is any element of Zn, then what is the order of k equal to? And let's get started by looking at a special case. If k is equal to 0, then I already know that 1 times 0 is equal to 0 mod n, and hence that says the order of 0 is going to be equal to 1. This is not a surprise. The order of a group identity is always going to be equal to 1. So now what I want to do is I want to assume that k is not equal to 0. So if k is anything other than 0, then I can say that L is equal to the order of k means that L is the smallest positive integer such that the multiple k times L is equal to the 0 inside my group, which is, of course, Zn. So I want to think about what that means. So L is equal to the order of k means L is the smallest positive integer such that k times L has to be congruent to 0 mod n, because the 0 element inside Zn is simply the equivalence class containing 0. But I know this. This fact here says something important. It says that KL has to be the smallest common multiple of k and n. It's got to be a multiple of k because k times L is a multiple of k. But k times L also has to be a multiple of n in order for KL to be congruent to 0 mod n. Now, I know a lot about the smallest common multiple. What that says is that L is equal to the order of k means L times k is the least common multiple of n and k. And as we saw in the previous video, the least common multiple of n and k is n times k divided by the GCD of n and k. So what we now have is that L is equal to the order of k means that L times k is equal to nk over GCD of n and k. And I'm going to divide both sides of this equation by k. And when I do, the k's on this side cancel, the k's on that side cancel, and we get L is equal to the order of k means that L itself is equal to n divided by the GCD of n and k. And so no matter what k I pick, the order of k is going to be equal to this expression. So to state it more properly, if k is inside Zn and k is not 0, then the order of k is nothing more than n divided by the GCD of n and k. Well, what are we going to do for generators? The order of k will equal n if and only if n times the GCD of n and k is equal to n, but that's going to happen if and only if I'm dividing by 1. In other words, the GCD of n and k is equal to 1. So what we now have is an important fact. K inside Zn under plus is a generator for Zn if and only if the GCD of n and k is exactly equal to 1. In other words, n and k have to be relatively prime. When n and k are not relatively prime, the order is simply going to be n divided by the GCD. And that will have some important implications for other considerations.